Have you seen all the SpaceX stuff going around social media lately? The launches, the giant booster, fire everywhere? If you have, you've probably just seen a massive rocket shooting flame and thought, okay, that's cool. But have you ever actually wondered how that thing gets off the ground in the first place? Let's talk about it, because here's the thing nobody tells you. These rockets weigh millions of pounds. We're talking more than 5,000 elephants just sitting on a launch pad. And somehow, that entire mass lifts itself straight up into the sky. So, how does something that heavy go anywhere but down? It actually comes down to one simple rule. Push something backward hard enough, and it pushes you forward just as hard. You know that feeling when you let go of a balloon without tying it? Air blasts out one end, and the balloon takes off in the opposite direction, flying all over the room? That's genuinely it. That's the whole secret. A rocket engine is just a massive, controlled version of that same balloon. Inside the engine, fuel and oxygen mix together and ignite, and that explosion gets aimed in exactly one direction, straight down, out the bottom, as fast as physically possible. And by that same pushback rule, the rocket gets shoved upward with just as much force going the other way. But here's where it actually gets hard. Gravity is pulling that rocket down the entire time, so the engines can't just push. They need to push harder than the rocket weighs every single second, or it just sits there. That number, thrust versus weight, is basically the whole ball game. It's the one thing that decides whether a rocket flies or just burns fuel on the pad going nowhere. So let's talk about the two rockets everyone brings up when this comes up. The Saturn V, the one that took astronauts to the moon, solved this with 5 absolutely massive engines called F1s. Each one burned kerosene and liquid oxygen, and together they made about 7.6 million pounds of thrust at liftoff. To this day, nothing has matched that using just 5 engines. Now, Starship, the one you've probably seen on your feed, went a completely different direction. Instead of 5 huge engines, its booster uses 33 smaller ones, called Raptors, all packed together, underneath it. Combined, they put out somewhere around 16 to 17 million pounds of thrust. That's almost double what the Saturn V made. So why would you use 33 small engines instead of just building a few giant ones? 2 reasons, honestly. Smaller engines are way easier to build consistently, especially if the plan is to fly this thing over and over again. And if one or even a few of those engines fail mid-flight, the rocket can usually just keep going on the rest. Lose 1 out of 5, that's a real problem. Lose 1 out of 33, you probably don't even notice. Okay, so once the rocket actually starts moving, there's another problem waiting. As it burns through fuel, it gets lighter, so the same thrust starts accelerating it faster and faster. But it's still dragging around these massive empty tanks it doesn't need anymore, and hauling that dead weight all the way to space would waste a ridiculous amount of energy, so the rocket just throws parts of itself away. Once the bottom section burns through its fuel, it detaches completely and falls off, and a second, much lighter section sitting right on top lights its own engines and keeps going. Stage by stage, it's shedding everything it no longer needs. The Saturn V did this the old way. Every stage just fell into the ocean and that was it, gone forever. And this is where Starship gets genuinely wild. Instead of throwing that first stage away, the plan is to fly it back down to the exact launch site and catch it out of the air using 2 giant mechanical arms built into the launch tower. Yeah, that's as insane as it sounds. Nothing this size had ever been caught out of the sky before this program tried it. And the reason they're doing all this? Reusability. A Saturn V engine got built once, flown once, and that was the end of it. But if a booster can land itself, get refueled, and fly again the very next day, the cost of getting to space doesn't just drop a little, it changes completely. So next time that clip shows up on your feed, that massive fireball lifting off the pad, you'll actually know what's happening underneath it. One simple rule of physics, the same one as a balloon losing air, scaled up to 17 million pounds of thrust.